Hi, I'm Rahul, and in this tutorial we are going to learn how to fit a simple linear regression model in Python. So here I'm going to use the Jupyter notebook, and I have installed the Anaconda distribution. So I'm running Python 3, and for this video I'm going to use the following libraries. First is pandas for data manipulation and loading the data, and statsmodels for fitting the linear model and for generating the fit statistics and report, matplotlib for plotting, and cbound for statistical plotting. So before starting, here we are going to load a real world data set that includes two variables. One is stat score and another is GPA score. So for simple linear regression case, fitting a linear regression, the dependent variable must be a continuous variable, not a discrete or multinomial variable. So it should be continuous first of all. And here we are going to predict the GPA score based on the SAT score using a simple linear regression. So first you have to import the libraries. First install those libraries using a pip method. You will get that how to install these libraries by searching in Google. So first install those such libraries and then import. Like here I am going to import the pandas as PD and statsmodels .api as sm, and matplotlib.pyplot as plt, and cbound as sns. So if you run the cell, it will import all the libraries, and as I have saved the simple linear regression SAT versus GPA data in a directory. So if this directory is your default directory, you can access the files using the ls function that will list all the files that contains under that directory. So if you run that, it will show that I have three files. One is simple linear regression using Python 3, linear regression using R, and simple linear regression.csv file. So this is the file we are going to import. So to import that, I'm using the pandas method pd.read_csv, and under that supplying the file with .csv extension, or file name with .csv extension, and saving in data. If you run that cell, it will import the data, and if you want to see the first 5 rows, use the data.head method, and it will show the SAT and GPA score. If you want more details or want to know about the data types, number of observations, number of NA values it contains, so you can go for the .info method. So by giving data.info method function, you'll get the details. The SAT is integer 64 with 84 observations, and it contains 84 observations and 2 columns or 2 variables. SAT has 84 observations and GPA also has 84 observations. The SAT is integer 64 and the GPA is float 64. So it has no NA values or missing values. So if you want to see the descriptive statistics like mean, median, mode, first quartile, second quartile, third quartile, then you can directly use the describe method. So just provide data.describe method, and if you run the cell, it will show the SAT and GPA, the count, mean, standard deviation, minimum, 25th percentile, 25th percentile, 50th percentile, 75th percentile, max. And if you want to check how what is the relationship and how the relationship status look like between SAT score and GPA score, whether it is a positively associated or negatively associated, you can plot the relationship using a scatter plot. So here I'm using the matplotlib.pyplot that we have imported as such a PLT. So here I'm plotting a scatter plot. So plt.scatter, you can use this such method or function and directly provide the x in x-axis SAT and y-axis GPA, and I'm giving the x level as SAT with font size 15 and y level as GPA and font size 15. And if you want to show that plot, use the plt.show. If you press Ctrl Enter, it will show the relationship between SAT and GPA score. That is if you see that with increase in SAT score, the GPA score increases. It is a positive linear association. or relation. So for fitting a simple linear model, first I'm saving the sat from the data, the sat variable in x1, that is our independent variable, and GPA in y, that is our dependent variable that we are going to predict based on this x1 or sat score. So first you have to initiate a constant. So use the sm that we have imported, the statsmodel.api we have imported as sm. So sm dot add constant, inside that give this x1, and save. I am saving this in x. Next, use the sm dot OLS, that ordinary list square, and inside that is give y, that is our dependent variable, then comma x, that is our independent that where we have saved that as a add constant term, and use the dot fit method that will fit the simple linear regression or fit the model, and I'm saving that in results. If you want run that cell, it will save or fit the model. And after that, if you use the summary method with this such a result object, then it will give you the full summary statistics of the OLS such a regression result. You can see the R square is such a 0.406, and I'm not going to talk about everything here. I'm interested in the SAT score and R square value here. In later video, I will discuss everything that this such a chart or this output contains. So here the first row is constant, and constant coefficients, standard error, t-value, probability values, and confidence interval, and the SAT coefficient. I'm interested in the SAT coefficient. How we'll interpret that one? Because it is a simple linear regression and there is a linear relationship or association between the SAT score and GPA, we can interpret it as like if SAT score goes or increases 1 unit, then the GPA score on an average will also increase by 0.0017. So it is a positive, the coefficient is positive, so it is a positive relationship between SAT and GPA. So next, if we want to plot the fitted regression line, we can do it in two methods. First, by calculating the y hat or the fitted y values using mx plus c, that is m is slope, x is the variable values or independent variable values, plus c, or sometimes people called b, that is the intercept value. So here we are calculating the y hat or fitted value using the first coefficient is that is slope value 0.0017. You can see here 0.0017 SAT score value, into we are multiplying by the x1 is our SAT score, plus the intercept value 0.0275. So it will multiply the slope with x1 and it also add the intercept value and it calculate the y hat and save in y hat. So first I'm going to plot the scatter plot. So plt.scatter and inside x1 comma y, and then I'm calculating the y hat, and over that scatter plot I want to plot the fitted regression line. So it's a plt.plot, that the plt.plot will plot a regression line. So inside that I'm giving the x1 the same values, but instead of y I'm giving now the y hat, so the fitted values, and color is orange and label is such a regression line. So next, the x level I'm giving as SAT and y level I'm giving as GPA, and it's a plt.show, it will show the fitted line. So here is the fitted line in orange color, and the same plot you can achieve by using the C1 package, that is a package for statistical plotting. So I have already imported that as the C1 package as SNS. So SNS.rig plot, that is regression plot. In X I'm giving the SAT, Y I'm giving the GPA, and data equal to data. And then X level is SAT, Y level is GPA, and it's a plt.show, it will show the plot. So SAT versus GPA, and the regression line here is in blue color, and this is the confidence interval, 95% confidence interval. So in this way you can fit a simple linear model, In next video, I am going to show you how to fit a multiple linear regression model and how to interpret the output or fit statistics or summary of the model. So thanks for watching.